So we're with Dr. Ann Condon, who is the head of the Computer Science Department at the University of British Columbia. Dr. Condon, I'm so glad that you're with us.
Thank you for having me.
Let's talk about, well, computer science, but let's talk about innovation, because that's what this conference is all about. Is there truly real innovation that is taking place in the technology field today?
Absolutely. It's a very exciting field, lots of innovation. At universities like UBC, where I work, or University of Washington here in Seattle, many of the students, many of the faculty have great ideas, are bringing them to commercial products. Everything from smart data storage that can make it easier for us to store data on the cloud and get access to our data more quickly. Health applications that can help people monitor their own health, have control over their own lives. Visual applications, for example, panorama stitch, stitching photographs together, even stitching movies together, 3D images together.
Oh, that sounds cool. Let's talk about that. Panorama stitch, how does that work?
Well, it uses techniques that have been developed in the area of machine learning in vision to understand images, which is actually very difficult for computers to do, and then understand which parts of completely different images are actually the same thing and automatically stitch them together to build a beautiful panorama from several photos that are of very small components of the overall image.
So as head of the computer science department, the whole thing, do you have time to work on some of the individual projects, or do you just get to learn about them from those who are working for you?
I get a little time to work on individual projects. I'm very interested in problems at the interface of computer science and the health sciences and biology. So I do work with people at the BC Cancer Research Agency on understanding what mutations in patients' genomes might actually be driving cancer, because if we understand specifically which mutations are causing cancer, then we can hopefully treat the cancers more effectively.
So you're in more than IT for the sake of gaming then, aren't you?
Yes, yeah. IT has applications in many, many areas of health, economic well-being, and so on. And it's just amazing to see what people in our department can do. Just as another example, one of our faculty members spent his sabbatical year in Uganda, and together with colleagues there developed mobile apps that can help farmers figure out where is the most profitable place to go in order to sell their goods, to trade their goods, so that they can reduce uncertainty, reduce time, and develop an economic means much more efficiently.
What I'm hearing you talk about sounds very consumer-oriented. I mean, really kind of almost retail.
Some of it is consumer-oriented for sure, but I think there are applications, to the environment as well. Another example would be somebody here at University of Washington, Shvetik Patel, who's developing smart technologies that can help us save energy in our buildings, in our institutions, and so on, to use energy more effectively. So there's consumer, but beyond consumer, I think also.
Dr. Condon, as head of the computer science department at a major university, I suspect you probably realize that there's not a whole lot of women that are doing what you're doing.
That's true. At our university, we're very fortunate that we have a relatively high percentage of women in our program. We work very hard to include women, to support women in the program. We have many combined majors because we find that many students, including women, like to combine their interest in technology with their interest in other disciplines, whether it's biology or the creative arts. So we find those are good ways to get more women into the program. You don't need to have a computer science background in high school to get into computer science in college. I think sometimes people don't understand that. You can come in and do very well right from the get-go in college.
From your experience in education, is there any reason why women are not just as capable, if not more capable than men in computer science?
No reason. In fact, we've just been doing a little analysis ourselves in our department. Right now, enrollment in computer science across North America is exploding. And unfortunately, we may need to raise the admissions threshold into our program just to hold steady. And we've done a little analysis to see would that adversely affect women, and we've discovered that actually women on average are doing quite a bit better in our program. So we don't see any problem there.
Speaking of education, there's been a huge change in particularly higher education thanks to IT.
That's true. And in computer science, I think we're seeing that more than other disciplines. You've probably heard of Moocs, massively online open courses.
Yes.
They've come out of computer scientists in Stanford, Google, and places like that. Well, again, in our department, we have developed a couple of Moocs. We're experimenting with how we can use them to better serve our own students. Ultimately, that is our mission, and that is what we want to do. We've developed tools and technologies that can help with peer evaluation and peer grading, so that students can learn from each other, can develop critical thinking skills in evaluating each other's essays according to a scheme that can be supported by technology. We're using a lot of different technologies in the classroom, and I mean the very simple one is just online videos that the students can watch beforehand, so that when they come into the classroom, they can talk to each other, problem solve with each other, learn from each other. I think that's a very simple but powerful way to use technology.
Dr. Condon, you're on the cutting edge of changes that are happening. Let's look 5 years down the road. You know, what are going to be the cutting edge changes that we're going to look to then?
I'd like to talk about 50 years down the road.
Okay, well, let's go 50 years
All right.
down.
One project that I'm interested in is molecular programming. So how do we write programs in DNA? How do we write programs that could work in our cells, could work in a wet environment as opposed to on silicon technology? I don't think we'll see these programs at a commercial scale in 5 years, but I hope we'll see them in 50 years, and I hope that they can help us sense and mediate the environment. It can help us help cure diseases in the cell, because if you have a program that can intelligently monitor what's going on, what changes are happening, and then respond in an intelligent way, as opposed to the very crude treatments we have now where you just apply radiation to every cell in the whole area regardless of whether it's healthy or not. I think there's a lot of potential there.
Dr. Condon, thank you very much for being with us.
Thank you.
Rainmaker believes we can change.